Hello everybody, I welcome you all to NK's geology class. Today I'll discuss about the polarization of light, how light is being polarized and why polarization is essential for study of rocks and minerals under petrological microscope or in OR microscope. So let us discuss what is polarization. It is actually a process of propagation of light through different minerals. Ordinary light propagates with vibrations taking place in all directions at right angles to the direction of propagation of light. If the directions of vibrations of light are made to take place in one plane at right angles to the direction of propagation of light, in that case only it is said to be polarized. So, polarization of light takes place when the light rays are forced to vibrate in one plane, perpendicular to the direction of propagation of light. In that case, we can say it has been polarized. And this polarized light is essential for study of optical properties of minerals, because when the microscope stage is being rotated, the plane polarized light passes through different planes of the minerals, and how is the behavior of those planes of the minerals to the light rays that are being detected in terms of the changes in optical properties shown by the minerals, and by virtue of which the minerals are being identified. That's why the polarized light is essential. And for this purpose, different devices are being used to produce polarized light, so that this light can be fruitfully utilized in the microscopes to study the optical properties of rocks and minerals. So, if you look at this diagram, this is the ordinary light which is vibrating in all directions at right angles to the direction of propagation. If this is the direction of propagation, light is vibrating in all directions. So here it is ordinary, because light is vibrating all directions at right angles to the direction of propagation. This is the direction of propagation. Lights are vibrating in all directions, And so this is ordinary light which vibrates in all directions at right angles to the direction of propagation of light. But when you say it has been polarized, let us say here it is this plane of the paper, we can say. Here the light is made to vibrate in one plane, say the plane of the paper, and here it has been polarized. So this is the direction of propagation, this is the direction of vibration, and the vibration is taking place in one plane, That's why it is said to be polarized. So we'll discuss how polarized light is being produced. Polarized light is being produced by passing the light through nickel prisms or through polarids. Polarids are a variety of nickel prism. And by passing the light through any anisotropic mineral where double refraction takes place, and the two rays which are being produced through double refraction are found to be polarized in their own planes. And also the natural absorption takes place in certain minerals in certain directions, so that those minerals, they behave as if they are the polarids. And also by reflection process, as per the Brewster's law, light can be polarized. So these are the methods by which we can get polarized light. Let us discuss a little about these processes or these methods, how we get polarized light. By polarizers, so polarizers are nothing but that the artificially prepared devices which are used to produce polarized light. And a common device is the nickel prism. Very common device is nickel prism. It is made out of a mineral called Iceland spar, or it is calcite, where E ray is allowed to pass through only, and it is in polarized state, and the O ray is absorbed as per the very construction of the nickel prism. So, one set of plain polarized light rays are allowed to pass through the mineral, and by this process, different optical properties of minerals are detected, by virtue of which the minerals are identified under microscope. If this is the ordinary light, here this is the ordinary light, and this is the nickel prism, and this light, when it enters into this mineral, which is a mineral that is calcite, which crystallizes in hexagonal system. So, light entering into this mineral is getting doubly refracted. These are the two rays. This is O ray, this is E ray. So, O ray is thrown to the sides of the prism where it is being absorbed. Nickel prism, O ray is absorbed by the walls of the prism, and E ray is allowed to pass through, vibrating parallel to the short diagonal of the nickel. Short diagonal of the rhombic face of the calcite. So, in case of nickel prism, one set of light rays vibrating parallel to the short diagonal of the calcite rhomb are allowed to pass through, and the other ray, that is O ray, which vibrates in a plane perpendicular to that of the E ray, is thrown to the sides of the prism, and where it is being absorbed by the black coating that is there in the nickel prism. So, in this process, by allowing the light to pass through the nickel prism, we get one set of light rays, and these light rays are very useful in optical study of minerals. Besides this, we have the double refraction in all the anisotropic minerals, by which we can get polarized light. The minerals which crystallize in non-cubic systems are doubly refracting, except those sections which are cut perpendicular to optic axis. So, I can just explain how it takes place. So, this is a mineral which is not belonging to cubic system, non-cubic systems, and the light rays are not passing along the optic axis direction, and here the ordinary light, which is incident at the interface of the unstable substance. So, here it is being split into two rays. One is obeying the rules of reflection refraction, that is ordinary ray, this is ordinary ray, and the other ray, which is found to be deviated even at the normal incidence, this is extraordinary ray because of its very deviation from normal incidence, disobeying the rules of refraction. This E ray, and E ray and O ray, they vibrate in two mutually perpendicular planes, and both are found to be polarized. So, we are getting two sets of polarized light rays. So, let us discuss a little about how these light rays are produced in different types of minerals. If we take any mineral which belongs to cubic system, the atomic structure of the mineral in cubic system are uniform in all directions. That's why any ray of light entering into such mineral is not found to be polarized. It remains ordinary ray. In any direction it moves. It is a case when we talk about cubic mineral. Any direction the light goes, it vibrates with equal ease in all directions and it never gets polarized. So this is a case in cubic system. But when you talk about the mineral of the tetragonal hexagonal system, which are said to be uniaxial minerals, in that case the c-axis direction is the direction along which there occurs no double refraction. This is the c-axis direction. C-axis direction, which is called as the optic axis direction, along which if light is moving, it is not found to be double refracted. So ordinary ray remains ordinary ray and it is not doubly refracted or it is not found to be polarized. But if light will be incident in such case in any other direction other than the optic axis direction, in that case light is found to be split up into two rays. One obeys the rules of the reflection, the other does not obey, that is extraordinary. So two rays are being produced and these two rays are polarized and these two rays they vibrate in two mutually perpendicular planes. So if the light is incident parallel to, if the light is moving parallel to c-axis or optic axis in case of uniaxial minerals, it is not found to be polarized. But in other direction it is found to be polarized. Similarly, if we take into account any biaxial mineral, biaxial minerals are found to possess two directions which are called optic axis direction and the angle between them is called 2V. In that case, if the light is moving parallel to these optic axis directions, then along those directions there occurs no double refraction or no polarization. But in other direction light is found to be polarized or there occurs double refraction or there occurs formation of two rays out of a single incident ray and these two rays are described as fast ray and slow ray and they vibrate in two mutually perpendicular planes and these two rays are found to be polarized. So light entering into any unstable substance is found to be polarized except the direction along which there occurs the optic axis. So light moving parallel to optic axis, we can say that there occurs no double refraction or no polarization. That has been discussed here. So in other directions of unstable substances, light is found to be polarized. So through passage of light into any unstable substance, there occurs double refraction and the two rays which are being produced, they are found to be polarized in two mutually perpendicular planes. Then let us discuss how by natural absorption we get polarized light. This natural absorption takes place in a mineral which is known as tourmaline. It is a mineral which is belonging to hexagonal system or uniaxial. It is a uniaxial mineral. So light passing through it are found to be doubly refracted and polarized. As I have already told, when the light is not moving parallel to c-axis, in that case it will be doubly refracted or it will be polarized. But here some deviation is found. There is one direction in which if the light gets incident over it, shows absorption of one ray and the propagation of the other ray in polarized state. So there occurs, so this is the case of natural absorption of light and it is controlled by the atomic structure of the solid mineral, because of which the absorption takes place. So it is controlled by the atomic structure. This atomic structure helps to absorb the light rays. As we know, light is a type of electromagnetic wave and the atoms, they have their electrical environment. So in case of the tourmaline, the atomic environment in certain direction is not found to be congenial for the passage of two rays. And one ray is being absorbed, the other is allowed to pass through. This fact happens in case of tourmaline and thus tourmaline acts as a natural medium or natural polaroid. So this direction along which we see this phenomenon is actually perpendicular to the optic axis. If light is incident over the tourmaline plate perpendicular to optic axis, in that case this phenomenon is observed. Let us say this is the section of a tourmaline mineral, vertical section. This is the c-axis direction as it has been shown here. And light is incident perpendicularly to this plane. This is prism face. And in that case, the light will pass straight and there will be two rays, one vibrating along this plane, one vibrating along this plane. This vibration, which is parallel to basal plane occurred or parallel to not one plane, that is found to be observed, and the vibrations which are parallel to c-axis, this is the c-axis direction, which are these vibrations, they are allowed to pass through. So, in case of this tourmaline, we see that this vibration parallel to c-axis is found to pass through, and this vibration which is parallel to basal plane 0001 plane, that is observed. And this vibration is belonging to O ray. This vibration is belonging to E ray. Because we have to remember here that E ray always moves through a plane that contains the incident ray and the c-axis. So this is the incident ray and this is the c-axis. So this is the plane in which the E ray vibrates. So E ray will have to vibrate like this. And O ray always vibrates in the basal plane. O ray always vibrates in the basal plane. And this ray, O ray, is not being allowed to pass through, and E ray is allowed to pass through. E ray is allowed to pass through, and it is the polarized ray. So, tourmaline acts as a natural Polaroid. Similarly, there is another method by which we can get polarized light, that is reflection. It takes place as per the Brewster's law. It takes place by reflection over glass slabs as per the Brewster's law. The reflected ray and the refracted ray produced by any incident ray over such a glass slab, if they make an angle of 90 degree between them, in that case both are found to be polarized. The reflected ray and the refracted ray both are found to be polarized. So the essential condition is that mu should be equal to tan I, tan of angle of incidence. In that case, the polarization takes place. So, if the light will be incident in this manner, so that this is the reflected ray, this is the refracted ray, the angle between them is 90 degree. In that case, mu will be tan I. And in this condition only we can get polarized light. So these are the different methods by which we can get polarized light. So polarized light can be obtained by reflection, polarized light can be obtained by refraction, polarized light can be obtained by natural absorption in tourmaline, polarized light can be obtained by passing the light through any unstable substance in a direction other than the optic axis direction. So this is all about polarization that I wanted to discuss, and I think I have tried my best to explain how polarization takes place and why polarization is required for optical study of rocks and minerals. Because the minerals present different atoms in different atomic planes. If the light reaction takes place along the atomic planes, then the character of light along those planes can be very well observed, and that's why polarized light is essential, or plane polarized light is essential for optical study, and that can be possible if we allow the light to pass through the polarites, or if we try to pass the light through natural absorption process, as it happens in case of tourmaline. So, polarization is essential process in which light is allowed to vibrate in one plane perpendicular to the direction of propagation of light. So, this is all about polarization, and thank you all for giving a patient hearing to this talk.